Welcome everyone, Metricom here, bringing you another explainer. Today, we're diving into something that is an absolute game changer for your construction sites, transforming environmental controls. We're talking about moving way past the idea of controls as just temporary paperwork or a box to check, and turning them into hard, engineered production constraints. If you've ever stood on a site and felt like your environmental plan looks amazing in a binder, but totally falls apart in the dirt, you are exactly in the right place.
So let's kick things off with a pretty common scenario. Why do controls fail by 10:30 a.m.? Picture this. It's 7 a.m. Your site looks pristine. Everything's tidy. The morning briefing is an absolute breeze. But then, mid-morning hits. The heat turns up, the wind kicks in, and the intense pressure of the daily schedule takes over. Suddenly, dust is blowing everywhere, water is pooling where it shouldn't be, and the whole thing just collapses. Why does this happen? Well, honestly, it's usually not a lack of caring. It's because the controls were never actually engineered into the job itself, and more importantly, they aren't being measured with hard data. When the pressure is on, fuzzy ownership and weak evidence just make the plan evaporate.
That brings us right into Section 1, Engineering Controls into Workflows. To really make this mindset shift, we use what we call the stickiness formula. Think about it. You would never just pour concrete without a precise engineered plan and strict quality checks, right? Well, environmental controls need that exact same rigor. This formula is a totally unyielding sequence. Step 1 is design. Before you even mobilize, you've got to translate requirements into site-specific layouts, drainage routes, and equipment choices. You bake these right into your method statements, not some standalone environmental plan that sits on a shelf. Step 2 is deploy. Make these controls highly visible, standardize your inspections with really clear pass-fail criteria, and build in definite stop-and-fix triggers. Finally, Step 3, verify. This has to happen every single day, measuring objective signals.
There's a quote I absolutely love that hits the nail on the head here. If you're missing the verification layer, you're running on hope. Without daily objective proof that your controls are actually working, your site is entirely vulnerable. And let's be real, hope is a wonderful thing in life, but it is a terrible management strategy for a busy construction site. If you can't prove a control is doing its job, you literally have to assume it isn't.
So what does real verification actually look like? Well, it means moving way past those subjective housekeeping walks. You need objective, daily signals. We're talking hard data here. That means pulling sensor logs from particulate matter monitors for dust or turbidity meters for water. It means collecting time-stamped photos that show the exact conditions before and after the work happens. You want to systematically track complaint data and keep an eye on inspection closure rates. This is how you audit the system itself, proving with actual numbers that your site is firmly under control.
Okay, let's move into Section 2, Managing Dust and Runoff.
Heading out into the field to tackle the most visible site impacts, you'll see a massive difference between a failing strategy and a winning one. Let's look at dust. Just spraying water everywhere? That's not a strategy. That's a temporary, reactive band-aid. What we really need is engineered dust control. This means attacking the problem right at the source. You install stabilized access points and wheel washes because trackout is the absolute #1 way dust spreads beyond your site boundary. You build hard stands and clearly mark your haul roads to stop heavy machinery from pulverizing soft ground into fine particulates. Basically, you engineer the site so the dust never even gets a chance to become airborne.
And to guarantee that actually happens, dust control has to become a daily production constraint. It needs to be a hard readiness gate that gets checked every single morning during coordination. You need to ask the tough questions. Are the water carts ready to go? Are the misting nozzles operational? Are our monitors online? If the answer is no, or if the wind exceeds a predetermined limit, earthworks do not happen, period. You literally tie environmental compliance directly to the permission to execute the work.
We see the exact same dynamic play out with water. Runoff failures usually happen because site drainage gets treated like temporary chaos. People slap down some silt fences and treat them like magic curtains that will somehow hold back a flood. That's what we call runoff hope. Runoff engineering, on the other hand, means actively designing the water's route. You use cutoff drains to keep clean water completely out of your disturbed zones. And you build sediment basins and traps that are actually sized for the real-world conditions of your specific site, catching that sediment long before it can move off property. So how do we know if we're winning? We use hard KPIs. For dust, your primary metric is not how many times you ran the water truck. It's the count and duration of boundary PM exceedances. You're keeping track of trackout incidents per week and how fast you're closing out non-conformance reports. For runoff, the ultimate failure is an off-site discharge incident. you need to be tracking turbidity exceedances per rain event. And crucially, you want a really high rate of your stormwater controls being visually inspected within 12 hours after it rains. That way you catch scours or bypasses the second they happen.
Which brings us to Section 3, keeping neighbors on side.
Let's pivot a bit to the human element. Managing your physical environment is obviously critical, but managing the people impacted by your site is what keeps the project moving smoothly. Honestly, neighbor impact is the ultimate project multiplier. Your site can be technically perfect, hitting every single emission target, and you can still completely lose your social license to operate if your communication is poor. We can't treat neighbors like obstacles or distractions. They are key project stakeholders. If you just surround them with noise, dust, and silence, they are absolutely going to escalate their issues.
This brings us to a really powerful communication standard to prevent that escalation. 1 hour. That should be your aggressive service level agreement, or SLA, for simply acknowledging a neighbor's complaint. When someone reaches out, they should never feel like they're shouting into the void. Having a dedicated hotline where every single complaint gets a response within an hour immediately diffuses tension. It shows them right away that you take their concerns seriously.
Right on the heels of that is our 24-hour target. Within 24 hours of that initial complaint, you need to deliver an action plan. Every complaint should trigger a quick mini-investigation. What time was it? What were we doing? What control broke down? And how are we fixing it? Within a day, you go back to that neighbor with evidence of closure. Simply publishing a "You Said, We Did" update builds massive overall credibility for your project. And remember, hard credibility will always beat PR spin.
All right, on to our final section, verification and hard governance. To make all these strategies for dust, runoff, and neighbors actually stick across months, changing seasons, and shifting schedules, you need a rock-solid governance layer. These are your non-negotiables. First, controls absolutely must be embedded directly into your inspection and test plans, your ITPs, and your permits to work. They can't live in a separate, ignored environmental folder. Second, roll out scored inspection regimes that actually track closure. Third, demand evidence packs. We want photos, sensor logs, and incident registers. Finally, subcontractor alignment is huge. These requirements have to be baked into their scopes, pre-starts, and performance reviews. You can even incentivize this by rewarding crews for sustained, long-term compliance rather than just hosting a one-off clean site day.
Let's put this into a highly actionable 30, 60, 90-day rollout plan. In your first 30 days, the goal is simply to stabilize. Map out your hotspots, get your baseline monitoring running, and fix the obvious control failures. By day 60, you standardize. Turn these controls into standard checklists, train up your supervisors, and start trending your KPIs every week. Then, by day 90, you lock in. This is the point where you kick off formal audits, strictly enforce your stop work triggers, and build an evidence set that gives absolute confidence to your clients and regulators.
Which leads us with one final thought to wrap up today's explainer. If you can't prove it's under control, it isn't. Environmental controls that actually stick aren't about printing more paperwork. They are about operationalizing performance. It's about engineering it right into the site so it's easy to do it right and genuinely hard to do it wrong. So here's my challenge to you. Stop relying on hope. Look at your site today and ask yourself, what is your data actually proving? Thanks so much for joining me for this Metrocom explainer, and I hope you walk away with the tools to truly take control of your site's environmental performance.